Hello, and welcome to another session at DaprCon. My name is Zohar. I'm a maintainer of Dapr, specifically of the docs. I am joined here by Simon, who has graciously accepted the offer to share some of his learnings and his journey as part of the man group to adopt Dapr. Hi, Simon. Welcome.
Hi, Ori. How are you doing?
Good. So can you tell us a little bit about Man Group and what you're doing over there, about the company, about yourself?
Sure. So my name is Simon Jones. I'm the head of platform engineering at Man Group, and my team focuses on the continuous evolution of our core trading platform and delivery processes. Man Group was founded in 1783. We're a publicly listed active investment management firm with over $135 billion in managed funds. And we operate in a highly regulated financial services industry where data privacy and security is paramount, as is platform stability to meet legal requirements such as time-sensitive trade reporting to regulatory institutions. So our applications, our services, our sensitive data are all primarily hosted in our private data centers that we own. They're geographically distributed with redundancies for disaster recovery. But there's very little that we have that leverages the cloud at this time. In terms of Man Group itself, we have several front office business investment management units. Each of them leverages the technology that's most appropriate for their needs. That could be Python for data science, machine learning, and rapid prototyping, to Java and .NET. We have a range of languages that we support. And the transactions from these front office systems, they all flow through our core trading and operations platform, which is primarily written in .NET. And it consists of hundreds of individual services and multiple promotional environments from dev all the way through to production. And our whole business needs to continuously innovate new financial products to stay competitive in what we all know as ever-changing market conditions. So we try to avoid large, expensive technology projects that have a long lead time before delivering value. Instead, we prefer to incrementally evolve our existing platform, which helps to maintain stability and extend the value of our previous development investment while continuing to meet the needs of this business with their need to rapidly evolve and create new products. What that means, though, is you end up with a platform that's been evolved over a long period of time, which now encompasses a wide range of framework versions, communication technologies, and hosting models, all of which you are continuing to maintain while you're continuing to build on top of that.
So that sounds like a critical system to the business that obviously has to be resilient. It's in a regulated industry and also has some legacy code in there, which I think a lot of people can relate to. Can we maybe take a look at the architecture even before maybe you use Dapr and how it looks like?
Yeah, that's a good idea. So we've got a diagram here which we can use to walk through how such a system may evolve over time. As we look at this, we're going to work from left to right across it. So starting on the left-hand side, what you see is, let's say you're starting out developing this platform like we did some time ago, and you decide to use Microsoft technologies at the time. And you're using things like Windows clients and servers. At the time, I chose .NET, the 3.5 framework with Windows Communication Foundation for API endpoints, maybe using TCP and XML, Windows service hosting, Windows authentication, a SQL Server backend, MSNQ for messaging, and maybe Windows Presentation Foundation for a front end. And this is what all was available as what may have been cutting edge at the time you started out. It's an integrated set of technologies that gives you rapid development, good tooling, a stable platform, and you deploy this to production and you start building on it. You roll out a number of services using that technology. And that's all working great. And then over time, newer versions of the .NET framework comes along, like .NET 4 up to .NET 4.8. And we can keep using everything that we had before in that on the left-hand side. We can use The same authorization, Windows authorization, we can use the same hosting, the user interfaces, MSMQ, all of this is still compatible with those frameworks. So that's fine. We can carry on building on those platforms. But then let's say in the client section, our other business units come along and they want to develop applications themselves, like the Java team have got an application they want to talk to our systems, or the Python team have. And we've been using Windows authentication with all of our services to identify clients and users, and they can use that as well because that's Kerberos, that's fine. But now the problem is the fact that we use WCF as a technology with TCP and XML, and that's less compatible, shall we say, with Java and Python. It's very much a .NET technology. However, WCF does support HTTP, JSON, REST type APIs like web services. So you can now leverage WCF to add a REST API to an existing service, or to a new service, I should say. And then those Java and Python apps can communicate your services. So you adopt a newer technology with as much of the existing that you can reuse to enable other clients to talk to your system. And then moving across, let's say the next thing that comes along is .NET Core, which we know came along, and it reached a stable long-term support version with 3.1. So you can still host that on a Windows service with Windows Auth if you want to use that, because it's new performance, new architecture, is what everything's moving to. It can still provide HTTP REST APIs like WCF, but on ASP.NET Core. But now the problem with .NET Core is it's not compatible with your messaging technology. Remember at the beginning, we started with MSMQ and we use that for all of our messages, but .NET Core systems can't use MSMQ. So what you need now is a cross-platform messaging solution that will work with .NET Core as well as with your Windows services. So you look around, let's say you choose Kafka, which is a centralized broker environment that does work cross-platform. And that now means that your .NET Core system can send and receive messages, but now you're probably going to need something that bridges your MSMQ messages across Kafka so that the new services on .NET Core can consume those. But again, you're building on what's there and you're just extending it, leaving what was there before, because that's fine, that's ticking along, and you're just adding new capabilities. Then you might decide to deploy these .NET Core services on Linux, because the developers decide that they like the idea of using things like containers for not just local debugging, but also for deploying to production to make that simple. So we can still use our Windows authentication technology with that. And we can host the Docker containers in a standalone Docker engine, so move from Windows service hosting to Docker hosting. And we don't actually need things like Kubernetes or an orchestration platform to do this. Just deploy single instance containers. And then some of these newer services that say aren't using a point-to-point technology like MSMQ, but are leveraging Kafka, they may want to create multiple instances so they can consume across multiple Kafka topic partitions for scaling and have throughput. So now you think that, okay, now we need to balance calls that are coming in across these instances if they have APIs as well. So you add a load balancer appliance, perhaps a hardware device. So any calls coming in that need to go to the APIs of those services can be distributed amongst them as well. And there are some issues that you do come across, like things like you need sticky sessions for the Windows authentication. There is some more complicated hard configuration to do with some of these, but it works and it gives you load balancing capabilities. But at some point, you're going to hit something that is going to require you to think about platform-wide changes. So this is incremental stuff you've been doing to now, but something's going to come along and make you think about, okay, I need to change the whole platform to use this. And that could be something like mobile device support. So the mobile device could be developed using a React Web UI and Node.js, but it's unlikely to support Windows authentication. It's most likely going to use something like OAuth to do the authentication of the client and user. And if your whole system is based on Windows Auth, you've now got to probably change some, if not all of it, to support OAuth and propagate it all the way through, which makes you think, okay, I need a way of applying new technologies consistently and new architectural patterns across the entire platform. That's such a range of frameworks and technologies that we're using. And so that's kind of where you get to when you start thinking, okay, what's available for us to be able to apply new features across this entire estate in one go?
Yeah, so I'm looking at this diagram and I'm seeing different platforms like Linux and Windows. I'm seeing different frameworks versions of .NET and even stuff that isn't .NET. I'm seeing different languages. And as you said, this is like a thing that happens because over time you're iterating and improving and having more scenarios come in. So what are the key things that you wanted to change or improve that made you look at Dapr?
Well, I think the key thing is, first of all, just to mention that the approach that we take is this incremental evolution approach. It retains our investment in our existing code and development, rather than rewriting everything. So it's very viable as an approach, but you do end, as you say, with these very wide range of technologies and frameworks over time. So there are some key things, though, that we wanted to add across the board. And when we decided we needed OAuth, we thought, let's look at what else we can put in at the same time. And the first thing actually was service discovery. So we wanted a consistent approach across the board to discovering and invoking other services. And ideally, what we wanted to have was dynamic service registration. We wanted every service to start up and register itself with a central registry and provide its own health checks so that the registry would know if it was available or not. And that would give us then things like automatic traffic routing for scaling and disaster recovery, failover, and reduce or eliminate the need for the physical load balancers, and also help with things like blue, green, or canary deployments, all of these features that you'd expect from a microservices type architecture. And we wanted to get these across the board. But another key one was distributed tracing. And we want to be able to trace call chains across the entire system, because that can actually help with a continuous evolution. It'll help with impact planning for service restructuring or replacement, because you know what services are calling that one you were looking at, and also what it's invoking as well by looking at the distributed tracing. Key performance bottlenecks, identifying those and things that you want to target as for update. And also things like even analyzing new releases for performance improvement and degradation. If you're constantly making changes, you want to see the impact of all of those changes as you make them, so you can respond to anything that might not have gone the way you expect. And also, we are all in intranet at the moment. It is all firewalled. It is in our own data centers. But we may at some point want to move that or expand into the cloud. So secure communications between our services is something that we think is a very important capability for deploying to environments with a variety of security controls. So that could be authenticating security calls between trusted service over MTLS, as an example, where you rotate certificates regularly, encrypt the service identity so you get enhanced access controls, more finely grained permissions, and reduce the surface area. And finally, we've had a lot of teams express interest in virtual actors. I know the technology's been around for a bit now. A lot of them are seeing things like Orleans, which is popular on the .NET platform. But our Python and Java and .NET teams are all interested in creating virtual actors that all communicate with each other for creating highly concurrent distributed solutions. So it's not necessarily a platform requirement, but it is an example of when the development teams come to us and say, look, we'd really like to see if there's a way of leveraging a technology across the board. So the challenge for us is always finding a way of introducing all of these capabilities and more across the entire platform in a consistent way.
Yeah, so it sounds, from my kind of being somebody familiar with Dapr, I heard service invocation, I heard observability, I heard MTLS, I heard actors, and what I'm seeing is an architecture which has multiple languages, has some legacy code, a lot of different technologies where you want to be agnostic. Sounds like Dapr would really be a good fit. Can you show us how maybe you integrated Dapr and maybe how this architecture looks like after Dapr is integrated?
Absolutely. So what we see now on the screen is another diagram that's a slightly modified version of the previous one, but showing how we could add Dapr to across the entire system. So the first thing is to deploy Dapr alongside every service instance. So Dapr is a single executable written in Go. It's a sidecar process. So you deploy that alongside every single service that you have. And on startup, the idea is that Dapr registers itself and that service in a central registry, so that every service then is able to discover any other service from that registry as if it's been Daprized and invoke calls through Dapr to those services. And Dapr gives us automated MTLS encryption between the sidecars. We just get that for free with the architecture. And it also provides automated distributed telemetry between the services as well. So any calls that we put through Dapr, we get the distributed telemetry, so we can trace the calls across the services. So just by adding Dapr to all of the services, we can build up this picture of the estate if we route a little calls through them. It supports and propagates OAuth credentials, both over gRPC and HTTP. And we've actually developed a simple technology, proxy technology, that allows us to route WCF calls through Dapr over to another WCF endpoint. So we can get distributed telemetry for our WCF calls as well by going through Dapr.
Oh, very cool.
And yeah, that was a big win for us, being able to do that. So we can add it across the board to provide a broad set of platform features in a consistent way. And it allows us to create virtual actors on Python and .NET and Java. So you can see how it's deployed everywhere and all the services, but what you also see there is an API gateway that we've created. And what that means is external applications can make calls into this gateway, and all they need to know is the Dapr app ID as part of the URL. And then we use Dapr under the hood to convert Windows authentications to an OAuth token, and we use Dapr to discover a healthy service, that app ID, and route the call through to that automatically, and then it's OAuth throughout the chain. And I have to say, what Dapr enables is pretty amazing. You know, being able to do this all with a single component across all these platforms and frameworks is quite remarkable.
Yeah, that's awesome. Now, you mentioned you're running this on-prem. And I'm seeing Dapr sidecars in each one of the servers and the API gateway as well. I know when I'm running Dapr locally, I've got the service discovery works through MDNS, and I think when it's deployed into Kubernetes, it uses the Kubernetes service discovery. But here you got VMs, so maybe that's a hint. But I'm seeing the HashiCorp console logo across the board. How are you? Yeah. How are you doing service discovery in this environment where it's on-prem? There's no orchestrator. How do these sidecars know where they are?
That's an excellent question. So we were following Dapr since the first time. I think it was announced by, I think it was Mark Russinovich at a Ignite conference in 2019. Yep. We started looking at it. We following it, got more stable, and as we were looking at it, we started playing around with it and trying it out. But because of our infrastructure, we quickly realized that we can't move to Kubernetes. It's just not an option because the number of services that are incompatible. We have to do everything with the architecture that we have. So we wanted to be able to use Dapr, but we needed service discovery, and you obviously can't use MDNS for that. So we'd long been considering HashiCorp console as a central service discovery registry, which doesn't require Kubernetes. Like Dapr, it's a single standalone executable. It's deployable cross-platform. So we started talking with the Dapr team of maintainers, which led us to developing and contributing the console service discovery component for Dapr. So we had to learn Go, but we had lots of help from the Dapr community, and we delivered that. And what that means is that the Dapr sidecar can now register itself and it's the service it's associated with console and startup, and discover other Dapr services through its own service discovery mechanism, which gives service invocation across physical hosts outside of an orchestration platform like KS, and it works really well.
That's terrific, and I think that's a great example of how a certain need that somebody who's using Dapr has can contribute and open up scenarios for the entire community. Because you made that contribution, that actually made service discovery like another building block, really, with components, the first one being console. And that's just available to everybody right now for these kind of scenarios. Another thing I was wondering about is, how are you initiating or spinning up those Dapr sidecars for each server? Because, again, in Kubernetes, we got this service plane, Dapr service plane service that is called the sidecar injector. In this case, again, you got VMs. How does the sidecar know to start with your application?
Well, the good thing about Dapr and the control plane services placement of Sentry, they're all cross-platform single instance executable, configured by the command line or external YAML file. So they don't need to be hosted in KS, but you do need to provide them on the application. You need to launch and bootstrap them and make them run. So what we did want was a seamless development experience for .NET developers, a way to press F5 in Visual Studio and have Dapr start and stop along with the application, to automatically restart Dapr if shut down for any reason, to configure it and assign its ports, to route all its JSON format console log messages back through the ASP.NET Core structured logging framework for visualization and things like Kibana, to combine the health checks with Dapr with that of the service, essentially treating Dapr as a critical component, almost like a DLL, reversing the way that it's launched, so it becomes a dependency of the application. And we want to be able to do that for Dapr, its sidecar, and for placement, and for Sentry to make it easy to deploy. So to achieve that, we created a lightweight component we call Dapr Sidekick, which we decided to open source to contribute back to the Dapr community.
Oh, that's very cool. Can you explain a little bit about Sidekick? What does it do?
I think it's probably easiest just to kind of show it as well, is to see what it actually does. It's probably the easiest thing.
Yeah, let's see a demo.
Okay. So this is the GitHub website for Dapr Sidekick on the Man Group site, and this is showing you all the information you need for Sidekick. It's available on NuGet as well. This describes how you install it. And in this area, we've got a samples folder, and we've got in the ASP.NET Core area, I've got a console sample, and we provide some information about how this works. There's some screenshots and things down here. We're going to use this now to demonstrate the use of Sidekick in .NET with console for service discovery.
Sounds good.
So I've got the console project here, and this is the Receiver and Ascender project, and this is basically the standard ASP.NET Core weather forecast application, but we've sidekicked it and we've consoled it. But just to show you initially, if I run this project standalone without doing anything else, then it comes up and it's just open to port on 8000. And I'm not going to show you that this is what's to open, this weather forecast. And this is all it's doing. It's just showing you weather forecast information. This is the standard .NET template. Now, how do I sidekick this? Okay, well, this is pretty easy. So in the startup, all I'm going to do is I'm going to add the sidekick component. And in the project, all I've done is bring in man Dapr Sidekick ASP.NET Core. And that's all I've done. I've literally done that. There was nothing else changed. I've just added a package reference and selected this. So this means I started again. And this time, a number of things happen. And what you'll see is it has discovered Dapr in the .dapr folder, because all I did initially was a Dapr in it. And it has started Dapr up, and it's given it some default settings, and it's given it, you see all the log messages from Dapr coming through into the console window, and it started up here fine. And if I was to just do a quick get process, we can see there's one Dapr running, 28256 is the process ID, and you can see 28256 is what it started. So it came up. If I stop my Visual Studio project, it sends the shutdown command to Dapr to stop. It waits a little bit of time for it to go away, finishes, and now if I do get process, Dapr is gone. So we automatically launch it and shut it down.
Dapr was started programmatically here, not with a CLI and not
exactly
injector, but through your code, really.
Yeah, cool. Our library will start Dapr automatically. It actually locates the executable, it configures it, it gives it the port assignments, it tells it to use JSON logging and routes it back through, it handles it all, and then it monitors the executable as it's running. So let's say I started again. And this time I'm going to show you, you see I've got process 1616 was started. What happens if I kill Dapr now? 1616. If I kill this process, and let me just bring this, change this screen so you can actually see it more easily. So you've got the two side by side. If I kill 1616, it immediately detects that Dapr's gone away. It says I'm going to restart it in 5 seconds. There's no Dapr process down here now, and it has restarted. If you look at the screen above, and if I check again, it's brought it back up again, and it's reconnected to it. So it will automatically restart it if it dies. So it's continually maintaining the state of it. And if I stop Visual Studio, then you'll see the process has gone away. So just F5, start and stop. There's one other thing I'll show here before we look at console, and that's just to show that if I bring in another bit here, I'm going to bring in health check endpoints. And what that means is that if I start this again now, and it'll bring up console again now, and I've still got my weather forecast here. But if I check my health on this endpoint, it says healthy. It says healthy at the moment. And if I now, let's see what Dapr it started, 23888. If I kill 23888 and I refresh this, it's gone unhealthy because Dapr's gone away. And in a couple of seconds, you'll see this go back to healthy again. And this is what's needed for console integration. It's us tracking the state of the thing that we own, essentially Dapr, and keeping track of the health status.
That's very cool. So you got the resiliency as well without an orchestrator. Can we take a look at the console bits?
Yes, absolutely. So console is a standalone executable. So I'm just going to launch console as a standalone agent right now in dev mode. And that means I can have my own console host running locally. And I go to console, and you can see here, console is started up. This is the local host. And the only thing registered with it now is console. So how do I change my existing project to support console? So what we can do is we can add a Dapr config YAML to our project, and it'll automatically get used and deployed with our project and used to configure Dapr. And I haven't got any console support in here yet, but I do now. So what this will do, this will basically say, I want to self-register the service on startup. It'll tell it the health endpoint to check, tell console what to check. And we register things like the Dapr ports. And also I'm adding some tracing here for Zipkin. So that's all I've done. I have literally just started that. If I start it up again now, and then we can take a look at console, and you can see it's come up here, console sample receiver, and it's gone healthy straight away because my service is healthy. So it's registered itself and it's running.
This is the Dapr sidecar talking to console, and console seeing that. You're using the console dashboard to actually see the sidecar.
Exactly right. And the cool thing now is if I was to kill this process, so let's see which one it just brought up. It brought up 38948. If I kill that, 38948, then if you watch the console when it's gone unhealthy straight away, I've killed Dapr. Console knows it's unhealthy because there's a unified health check endpoint in the service. And now it's gone healthy again because we restarted Dapr and it came back again. So you can see how console's constantly monitoring it.
That's very cool.
Yeah, but it gets better. So what I can do now is start two projects together. So I've got another project here, a sender project. This is also configured to self-register with Dapr on startup. But this has got a controller method on it that is going to actually invoke the weather forecast endpoint on the console sample receiver project, which is this one. This is the app ID that gets registered with Dapr in console. And all I'm doing here is creating an HTTP client to talk to that app ID on that remote console registered service through Dapr to invoke that same weather forecast endpoint. So sender service, going through its own Dapr sidecar over to the Dapr sidecar of the receiver service, executing the weather forecast, returning the result via console registration, and both of them bootstrapping and running Dapr automatically. And this is how it would work across multiple hosts. So if I run this one now, we get two services coming up. That's the one, and the other one is here. Let's come up again. There we go. It's running. It's running. And if I go back to console, you'll see I've got two services here now, sender and receiver. And what this has done, this has brought up a little Swagger UI for me here. This is the sender Swagger UI. I've got a sender Dapr weather forecast. This is the controller method we were just looking at. And if I execute this, this gives me a weather forecast back. I've received it. I've just called Dapr weather forecast on that controller. And if you go to Zipkin now, for example, because this is all going through the Dapr sidecars to prove to you that I just did a distributed call, I can go to Zipkin. I now have a call in Zipkin. And if you look at this, this is showing that the console sender application called the receiver application. So I've got my automatic distributed tracing over Dapr for free.
That's great, Simon. Looks like we're out of time. I think we've seen console used for service discovery. We've seen the sidekick that lets you programmatically start Dapr as and have that resiliency, and that's a great addition as well. Plus the observability you get through it. So these are awesome contributions. Sidekick is open source. Obviously, console has been contributed, so that's available to the community. I think this is a terrific example of a company kind of taking on Dapr, having legacy code, being in a regulated industry, so it's not really easy to take these things in, but still being tremendously innovative and forward-looking. Thank you so much, Simon, for sharing all this and showing us.
It's a pleasure.
Yeah, and thank you, all of you, for joining us and tuning in. Have a great DaprCon. Thank you.
Thank you.